When running multiple current-carrying conductors in a conduit, derating becomes a crucial consideration to ensure safe and efficient operation. Derating refers to the reduction in the allowable ampacity of conductors due to the presence of multiple conductors within a confined space, such as a conduit. The National Electrical Code, specifically Article 310.15b3, addresses this issue. When 3 or more current-carrying conductors are installed in a raceway or conduit, the allowable ampacity of each conductor must be reduced according to Table 310.15b3. This reduction is necessary because conductors generate heat when carrying current, and when multiple conductors are bundled together in a conduit, the heat buildup can exceed the insulation's temperature rating, potentially leading to insulation damage, reduced conductor lifespan, and even fire hazards. To determine the appropriate derating factor, you need to consider the number of current-carrying conductors in the conduit. The NEC provides a table that lists the derating factors for various numbers of conductors. For example, if you have 4 to 6 current-carrying conductors in a conduit, the allowable ampacity of each conductor is reduced to 80% of its original value. If you have 7 to 9 conductors, the ampacity is reduced to 70%, and so on. It's important to note that equipment grounding conductors and bonding conductors are typically not considered current-carrying conductors for derating purposes, as they only carry current during fault conditions. However, neutral conductors in certain circuits, such as multi-wire branch circuits, may be considered current-carrying conductors and must be included in the derating calculations. To calculate the maximum number of conductors that can be installed in a conduit while adhering to derating requirements, you need to consider several factors. Firstly, the ampacity of the conductor. Secondly, the derating factor based on the number of conductors. And thirdly, the cross-sectional area of the conduit. The cross-sectional area of the conduit is determined by its trade size. For example, a 2-inch conduit has a specific internal area that can accommodate a certain number of conductors. The NEC provides tables that list the allowable conduit fill for various types of conduits and conductors. To determine the maximum number of conductors, you would start by selecting the appropriate conductor size based on the load requirements. Then, you would determine the ampacity of the conductor based on its insulation type and temperature rating. Next, you would calculate the derated ampacity by multiplying the conductor's ampacity by the appropriate derating factor from Table 310.15b3. Finally, you would consult the conduit fill tables in the NEC to determine the maximum number of conductors of that size that can be installed in the conduit without exceeding the allowable fill percentage. It's important to note that the NEC also specifies requirements for conductor spacing and arrangement within the conduit. Conductors must be installed in a manner that allows for adequate heat dissipation. In some cases, it may be necessary to use larger conduit sizes or to reduce the number of conductors in a conduit to comply with these requirements. In addition to derating for the number of conductors, derating may also be required for ambient temperature. If the ambient temperature around the conduit exceeds 86 degrees Fahrenheit or 30 degrees Celsius, the allowable ampacity of the conductors must be further reduced. The NEC provides correction factors for various ambient temperatures. These correction factors are applied to the derated ampacity to determine the final allowable ampacity of the conductors. It is essential to consult the NEC and other relevant electrical codes and standards to ensure that you are following all applicable requirements for conduit fill and derating. Failure to comply with these requirements can result in overheating, insulation damage, reduced conductor lifespan, and even fire hazards. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about conduit fill and derating. They can help you to ensure that your electrical installations are safe and code compliant. To provide a more detailed explanation, let's consider a scenario involving a 2-inch conduit containing THHN copper conductors. THHN conductors have a temperature rating of 90 degrees Celsius, which allows for a higher ampacity compared to conductors with low temperature ratings. However, the ampacity must still be derated when multiple conductors are installed in the same conduit. Assuming we have 6 current carrying THHN copper conductors in a 2-inch conduit, we would need to apply a derating factor of 80% according to table 310.15b3. If each conductor has an initial ampacity of 90 amps at 90 degrees Celsius, the derated ampacity would be 90 amps multiplied by 0.8, which equals 72 amps. This means that each conductor can only carry a maximum of 72 amps in this configuration. Next, we need to check the conduit fill tables in the NEC to ensure that the 2-inch conduit can accommodate 6 THHN conductors of the size required to carry 72 amps. The conduit fill tables specify the maximum number of conductors of a given size that can be installed in a particular conduit size. If the conduit fill tables indicate that a 2-inch conduit can accommodate 6 THHN conductors of the required size, then the installation would be compliant. However, if the conduit fill tables indicate that the 2-inch conduit cannot accommodate 6 THHN conductors of the required size, then we would need to either increase the conduit size or reduce the number of conductors. In some cases, it may be possible to use smaller conductors with a higher temperature rating to reduce the overall conduit fill. For example, if we use THHN 90 degrees Celsius conductors instead of THHN 75 degrees Celsius conductors, we may be able to reduce the conductor size and thus reduce the conduit fill. However, it's important to ensure that the smaller conductors can still safely carry the required load current after derating. In addition to conduit fill and derating, it's also important to consider the bending radius of the conduit. The NEC specifies minimum bending radii for conduits to prevent damage to the conductors during installation. Sharp bends can damage the conductor insulation and reduce the ampacity of the conductors. Therefore, it's important to use proper bending equipment and techniques to ensure that the conduit is bent to the correct radius. Furthermore, it's important to properly support the conduit to prevent it from sagging or becoming damaged. The NEC specifies requirements for conduit supports, including the maximum spacing between supports. Proper support is essential to maintain the integrity of the conduit system and to prevent damage to the conductors. When installing conductors in a conduit, it's important to use a suitable pulling lubricant to reduce friction and prevent damage to the conductor insulation. The pulling lubricant should be compatible with the conductor insulation and the conduit material. It's also important to avoid overfilling the conduit with lubricant, as this can create a hydraulic lock and make it difficult to pull the conductors. After the conductors have been installed in the conduit, it's important to properly terminate them at the electrical panels or equipment. The terminations must be made in accordance with the NEC and the manufacturer's instructions. Proper terminations are essential to ensure reliable and safe electrical connection. Finally, it's important to test the completed electrical installation to ensure that it is functioning properly and that it meets all applicable codes and standards. Testing should include insulation resistance testing, continuity testing, and voltage testing. Any deficiencies should be corrected before the electrical installation is put into service. In summary, conduit fill and derating are critical considerations when designing and installing electrical systems. By following the requirements of the NEC and other relevant codes and standards, you can ensure that your electrical installations are safe, reliable, and code compliant. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about conduit fill and derating. They can provide you with expert guidance and assistance to ensure that your electrical installations are done correctly. In the specific scenario of a 12 by 12 by 6-inch gutter with two 2-inch conduits, one for feeders and one for circuitry, the need for derating within the 2-inch conduit depends on the number of current carrying conductors within that conduit. If the number of current carrying conductors in either of the 2-inch conduits is 3 or more, then derating according to NEC table 310.15b3 is required. The calculation for the maximum number of wires in the conduit involves firstly determining the conductor size and insulation type based on the load requirements, secondly finding the allowable ampacity of the conductor from NEC tables or stroke alif lam or stroke alif, applying the appropriate derating factor based on the number of current carrying conductors in the conduit ot alif bat ain alif, checking the conduit fill tables and the NEC to ensure that the chosen conduit size could accommodate the number of conductors after derating. The example calculation provided maximum number of wires equals cross-sectional area multiplied by derating factor divided by ampacity per wire. Maximum number of wires equals 3.14 multiplied by 0.8 divided by 90. Maximum number of wires equals 0.28, leading to the conclusion that only one THHN copper wire with a 90 amp ampacity can fit, is a simplification. The correct approach involves using the conduit fill tables in Chapter 9 of the NEC, which specify the maximum number of conductors of a given size and type that can be installed in a particular conduit size. The cross-sectional area of the conductors, including insulation, must be considered. For example, using Table 4 in Chapter 9, you would find the cross-sectional area of the conductor you intend to use and then use Table 5 to determine the maximum number of conductors permitted in a 2-inch conduit. Derating factors from 310.15b3 must still be applied to the allowable ampacity of the conductors based on the number of current carrying conductors.